Today, we're diving into one of the internet's most powerful weapons of disruption, the denial of service attack. In a world that pretty much runs on being connected all the time, the power to just shut something down, well, that's a really serious threat. So let's break down how it all works.
We've all been there, right? You're trying to log in, maybe stream a show or jump into a game, and suddenly, poof, nothing. The service is just down. And it's not your internet. It's down for everyone. That kind of widespread outage, a lot of the time, that's not some random glitch. It's a deliberate, targeted attack.
So, to really get how this works, let's use a little analogy. Imagine your favorite online service is a super popular, bustling restaurant. The simplest type of attack, the starting point, is what we'll call the lone blocker.
A standard denial of service, or DOS attack, is basically a one-on-one showdown. You have one attacker going after one target, and their goal is incredibly simple: cause so much chaos that nobody else can get in. It's literally like one person just standing in the doorway of that restaurant, physically blocking the entrance for everyone.
Now, this blocker has a few different moves. They can try to flood the entrance, which is the network, with so much junk traffic that legit customers can't even get close. Or they can tie up the staff, overwhelming the server's brainpower and memory. And another classic move? They can book every single table, using up all the server's available connections so there's just none left for anyone else.
But here's the thing. A lone blocker is, relatively easy to deal with. The real threat, the scary one, is when that attacker decides to bring an army. That's when a simple disruption turns into something way, way more dangerous.
And that brings us to the Distributed Denial of Service Attack, or DDoS. This is a whole different beast. It's not just one person at the door anymore. It's a massive coordinated flash mob swarming the restaurant from every single direction. The attack is coming from countless sources all at once, which makes it incredibly hard to stop.
And when I say countless, I mean it. We're not talking about just a few computers here. We're talking about an army of potentially thousands of devices, laptops, phones, even your smart fridge or security camera, all launching a coordinated assault on one target at the exact same time.
So, where does this massive army even come from? It's called a botnet. Here's how it works. An attacker infects all sorts of everyday devices with malware, turning them into what we call zombies. These zombies then form a huge network that the attacker can command from afar, all without the device owners having any clue that their machine is part of an attack. So, to put it simply, a DOS attack is one-on-one. That makes it much easier to spot the attacker and block them. But a DDoS attack? That's a many-on-one assault. The sheer volume of traffic coming from so many different places makes it an absolute nightmare to trace the real source and defend against it.
So, what does this zombie army actually do? Attackers have a whole playbook of tactics, and their motivations can be anything from just causing chaos for fun to sabotaging a competitor to extortion or even political protest.
All right, the first and most common tactic is basically the digital equivalent of a tidal wave. The goal here isn't to be clever or sneaky, it's just to overwhelm the target with sheer brute force volume.
These are called volumetric attacks. The whole point is just to create a digital traffic jam so massive that nothing can get through. The botnet sends a flood of data that completely eats up the target's internet connection, meaning legitimate users just can't find a way in.
But attackers don't always go for brute force. Sometimes they use a much more clever approach, one that's designed to confuse and completely exhaust the target's systems. These are known as state exhaustion attacks. Instead of just clogging the pipes, they cleverly go after the server itself. Think of it like the mob sending in thousands of bizarre, incomplete orders. The restaurant staff, the server, gets so busy trying to figure out these nonsensical requests that it wastes all its resources and eventually just crashes.
A classic example of this is called a SYN flood. It's basically a massive prank call. First, a zombie computer sends a request to the server, saying, "Hey, can we talk?" The server, being polite, replies, "Yes, I'm ready for you," and it holds a spot open. But the zombie, which used a fake phone number, never replies back. It just goes silent.
So the server is just left hanging, holding a connection open for a customer who's never going to show up. Now multiply that by thousands of these ghost requests every second. Pretty soon, every single line is tied up, leaving absolutely no room for real users.
The third tactic is the most sophisticated of all. It doesn't target the network or the connections. Nope, this one targets the actual application running on the server, the restaurant's own ordering system. These are called application layer attacks, and they are so sneaky because they often look just like legitimate traffic. Instead of a huge flood, an attacker might find one very specific, complex request that they know is really hard for the server to process, like a complicated search. By just repeating that one difficult request over and over, it's enough to grind the entire service to a halt.
Okay, so faced with this kind of absolute chaos, how can any service possibly defend itself? Well, the answer really lies in having multiple layers of security.
First off, you've got your basic defenses. Let's call it the Bouncer's Toolkit. You can increase your bandwidth, which is like getting a bigger front door. You can filter traffic, kind of like checking IDs to spot known troublemakers. You can use rate limiting, which only lets a certain number of people in at a time. And of course, you keep your software updated to patch any weaknesses.
But let's be honest, these basic defenses often just aren't enough to stop a huge DDoS attack. When that zombie army shows up, your single bouncer is going to get completely overwhelmed. You need a dedicated, powerful security service.
And this is how modern protection works. All of a website's traffic, both the good and the bad, gets sent to a cloud protection provider first. Think of them as a massive off-site security team. Their specialized systems analyze everything, scrub out all the malicious attack traffic, and then they only send the clean, legitimate user requests back to the server. And that really brings us to the final crucial question. These attacks aren't just some technical annoyance. For businesses, for governments, for critical services, being taken offline means lost money and broken trust. In our incredibly interconnected world, the ability to stay online isn't just a convenience anymore. It's an absolute necessity.